Welcome to Chapter 23, Firm Supply. The fundamental decision that each firm has to make is how much to produce and what price to set. But they don't have complete freedom in determining either decision, how much to produce or the price to set. The decision of how much they can feasibly produce is subject to a technology constraint. And we covered those in Chapter 19 that defined how the firm is able to transform inputs into the output that they sell. And then the price that they set is subject to the market constraint. So what kind of market is the firm in? Are they in a perfectly competitive market? Are they in a monopoly? Is it somewhere in the middle? So in this particular chapter, we're going to assume the perfectly competitive market structure. And you are familiar with these from the prerequisite course in Intro Micro. Varian, in his text, defines pure competition or the perfectly competitive market as a market where each firm assumes that the market price is independent of its own output level. Now, when I think of the perfectly competitive market is actually a theoretical construct. Economists don't believe that the perfectly competitive market actually exists anywhere because its assumptions are very demanding. You can always find at least some assumption of the perfectly competitive market that's violated in practice. But it's an ideal, a theoretical construct that we use to describe market behavior. One example that's frequently used to illustrate a perfectly competitive market, it comes very close, but it's not a perfect match, is that of agriculture. And I'm particularly fond of that example because my dad was a commercial wheat farmer. So I grew up on a farm. So when I think of the perfectly competitive market structure, I always think of it in terms of agriculture. There are many buyers and sellers. Now, my dad grew wheat. He was a wheat farmer in northeast Colorado. There are many buyers for wheat, right? When you eat bread of any sort, you are an ultimate consumer of wheat. And there are hundreds and thousands of wheat farmers throughout the country. So there are a large number of buyers and sellers in the market for wheat. The product is homogeneous, meaning that the wheat produced by any farmer is the same as that produced by any other farmer, broadly speaking. If each firm or each farm is small relative to the market, as my dad was, Dad believed that he could sell any amount of wheat that he could feasibly produce and it would not affect the prevailing market price. So the market price is determined by the Chicago Board of Trade. And I remember my dad would tune in to the AM Superstation in Denver every day at 3:15 and listen to what the closing price was of number 2 hard red winter wheat FOB Chicago. That was the topic of discussion every afternoon at 3:15. So Dad was a price taker, right? The choice that was presented him each day when he got that price from the Chicago Board of Trade, he could either accept that price and sell any amount of wheat that he could feasibly produce, or if he rejected it, he couldn't demand a higher price, right? No one would be willing to pay it because Dad's wheat was homogeneous. It was identical to that produced by any other wheat farmer in the country. So when we combine all these elements, we get this diagram that you see to my left, where there is a market demand for wheat. The market demand for wheat is determined at the Chicago Board of Trade. It's the willingness of traders to purchase wheat wholesale. And then the equilibrium price is determined. So that would be where market supply intersects market demand. And then that green horizontal line represents firm demand. So Dad believes that he could sell any amount at the going price, and if he demanded a price a penny above P star, then you'll notice that the green firm demand curve hits the horizontal axis, the vertical axis, and goes straight up, meaning that Dad is unable to sell any wheat at any price above P star. Now, the problem of firm profit maximization within a perfectly competitive market, it's actually a very neat mathematical optimization exercise. We know that profit is total revenue minus total cost. We've spent the last several chapters detailing what total cost is. Total revenue is the price that the firm charges times the output that they produce. And we just established in the previous slide that within a perfectly competitive market, firms are price takers. What that means is P is fixed. In Dad's case, it was by the Chicago Board of Trade. So Dad's problem is to choose the output level Y to maximize profit as written. And of course, we know how to maximize any function mathematically. You take the derivative of it and set it equal to 0. So if I take the derivative, I get price minus marginal cost is equal to 0. And now you'll notice that this function that I've drawn to my left, I have profit, and this is a cubic function. The reason I've drawn this particular shape is that if the firm produces no output, so Y is 0, that vertical intercept is equal to fixed costs. So as the firm begins output, we have profit declines even more, and we get this local minima, and then profit increases, and we get to the second point to the right where the slope is equal to 0. And then and of course this is the short run, right? So in the short run, the law of diminishing marginal products sets in, and as the firm tries to increase output after the law of diminishing marginal products sets in, profit precipitously declines. Now you'll notice that if I say, oh well, the way to maximize any function is to find the place where the derivative is equal to 0, you'll notice for this particular type of function I've drawn, there are two places where the derivative is equal to 0. And so one of these is the local minima, the other one is the profit maximizing output. How would I tell them apart mathematically? Well, the way we would do this, if you were talking to your friends in the math department, is we take the second derivative. So if the first derivative is the slope of the profit function, the second, so the slope tells me how profit changes as output changes, or the tangency. The second derivative says how is the slope changing as output changes. So the second derivative tells me, is the slope increasing or decreasing? Now you'll notice at the first place on my left, where the first derivative was equal to 0, the profit minimizing point, if I consider an output level slightly before, you'll notice that what happens is the slope is increasing, right? It goes negative, 0, positive. So as the level of output increases, the slope is increasing. And in the second case, the profit maximizing point, as output increases, the slope is positive, it becomes 0, and then it turns negative. So at the profit maximizing point, the slope is decreasing. So we could characterize the profit maximizing level of output for the firm as where the slope of the profit function is equal to 0 and the slope is decreasing. So to state it in a little less antiseptic mathematical way, it's the point where the output level where price is equal to marginal cost, and this second derivative, which is equal to minus the derivative of marginal cost with respect to output. Well, that's negative the slope of the marginal cost curve. So what I can say then is, actually I've summarized it on the next click here. Profit is maximized where at the level of output where price is equal to marginal cost and marginal cost is upward sloping. So if negative slope of marginal cost is less than 0, what that means is the slope of the marginal cost curve is increasing. It's upward sloping. So if I return to the cost diagram that I developed in the previous slide, I've highlighted this area now in green. So what we've learned from the previous slide is that the firm produces output, or what we've proposed initially is that the firm chooses the output level where price is equal to marginal cost and the marginal cost curve is upward sloping. And so we get the green area. Now, if we think about this a little more carefully, we can refine it more. What does the firm do if it's losing money or the economic profit is less than 0? If a firm shuts down in the short run, they still have to pay their fixed costs. Remember, fixed costs are defined as costs that are paid regardless of the output level. So fixed costs have to be paid also if the firm shuts down. So this might be interest on debt. It might be lease payments on equipment, those sorts of things. So let me propose that so if the firm literally shuts down, it's going to earn a profit of minus F. So I claim that if the firm is producing output and they generate a profit of minus F, that will occur when price is equal to the average variable cost. Okay, that's my proposal. And here's how we could show that that's indeed true. So profit is total revenue minus total costs. Total revenue, so if price is equal to average variable cost, what I could do in that second line is I've substituted average variable cost for the price level. And then I've also expanded out what total cost is equal to. Now, average variable cost is defined as variable cost divided by output. I've multiplied that by output, and then the definition of total cost is left the same as it was in the previous line. Now you'll notice that the output level in the first term can cancel. It appears in both the numerator and the denominator, and I get variable cost minus fixed costs. Variable costs cancel out, and profit is actually equal to fixed costs. So what I've just shown with these few equations is that if price is equal to average variable cost, then the firm's profit is minus F. So I claim that the short run firm supply, the firm will choose the output level where price is equal to marginal cost if the price level is greater than or equal to average variable cost. If the price level is less than the minimum of average variable cost, then the firm shuts down. Right? Because remember, when price was equal to average variable cost, the firm's profit level was minus F. If the firm produces a level of output less than that quantity, they will lose more than F dollars. So in the short run, if the firm is losing money, they will never want to lose more than F. F is the minimum that they're willing to tolerate. So what I have then is now this green line showing the firm's supply curve. So we have a vertical line that goes from the origin up to the point, the price where marginal cost is equal to average variable cost. There's a discontinuity, but I've indicated that on the diagram to my left with a dashed green line, and then it's the marginal cost curve from that intersection of marginal cost and average variable cost on upward. So this shows me the quantity that the firm is willing to produce at any price that they see in the marketplace. Okay. Now, to do this mathematically without a diagram, at least initially so, here we have the quadratic cost function that we first saw in the previous chapter. Marginal cost, you remember, is the derivative of total cost with respect to output, which was equal to 2y. What I claim then is that the supply function for the firm, you remember, they choose the output level where price is equal to marginal cost. So what I will do is I will take my marginal cost function, which is 2y, set it equal to price, and then I rearrange it to get output level on the left-hand side and everything else shoved on the right-hand side of the equality. So that's the one line up from the bottom, y is equal to 2p. And what I can state then is this is the firm's short-run supply curve. Whatever price it sees, this firm will produce that price divided by 2 units of output. So you recall that marginal cost was linear in this example. It starts at the origin and goes up at a slope of 2. So that is the supply curve for this particular type of firm. Okay. Profit, of course, is total revenue minus total cost, and you think about how to illustrate that on this firm cost diagram. Total revenue is pretty easy. We take whatever price the firm sees, which is P star. We take P star over to where it intersects the marginal cost curve. That defines the level of output. So Y star, the level of output, is defined by where the price P star intersects the marginal cost curve. So that large area represents total revenue. Total cost can be illustrated cleverly on a graph like this as average cost times output. And the reason why is average cost, you remember, is total cost divided by the output level. And you'll see in the third line, or one line up from the bottom, the Y stars in numerator and denominator cancel out. And I can say then that when I project Y star up to the average cost curve and then over to the vertical axis, that lower white rectangle represents total cost. So since the larger rectangle, almost square-like, is total revenue, the white rectangle represents total cost. The green shaded region, which is the difference between total revenue and total cost, now represents profit. Okay. Producer surplus is defined as the difference between what the firm receives and for their output, which is P star, the price they see in from the marketplace, and the reservation price, which was the minimum that they were willing to accept to produce the units of output. And you might remember that the reservation price is equal to the marginal cost. Right? Marginal costs were the direct costs that the firm endured for producing the last unit of output. So producer surplus could be illustrated as total revenue, which is P star times Y star. So it's the big rectangle. and then we subtract from it the firm's reservation price, or their minimum willingness to pay. So that's given by the marginal cost curve. And then when we get to the intersection of marginal cost and average variable cost, we project a straight line over. So the green shaded region represents producer surplus. There are actually two more ways that we could graph producer surplus. The second one is that we could also describe average variable costs as, so if producer surplus is total revenue minus variable costs, what we could say then is that variable costs could be represented graphically as where Y star intersects average variable costs and then project over. So the difference between total revenue and variable costs is a second definition for producer surplus. Okay. A third definition, you remember we covered in the previous chapter that by the fundamental theorem of calculus, total variable or variable costs are also equal to the area underneath the marginal cost curve. So we could take total revenue as before, and we could subtract off variable costs as the area underneath the marginal cost curve. And then we get this third graphical definition of what producer surplus is. Either one works. Okay. In the long run, I won't say the silly definition, but the serious definition you recall is that there are no fixed costs. So if a firm is earning negative economic profit, that's intolerable in the long run. You remember, in the short run, the firm was willing to operate at a small loss as long as it was no bigger than fixed costs. The fixed costs have to be paid whether the firm produces any output or not. So we use that logic to determine that the firm was willing to remain in operation and lose money in the short run up to F. But in the long run, since there are no fixed costs, all factors of production are allocated to their most productive use. So if a firm is earning negative economic profit, in the long run, those factors of production will be used in their profit, in their more profitable use. Okay. So what we can say then is, in the long run, the firm's supply curve is the output level where price is equal to marginal cost above the minimum of the average cost curve. So you'll notice that the green individual firm supply line starts at the origin, it goes up, then there's the discontinuous region that I show with dashes, and it hits the place where marginal cost intersects average cost, and then it follows the marginal cost curve on up. So a firm must earn 0 or greater economic profits in the long run, otherwise it will shut down and liquidate. Okay. So quiz questions. Remember, we were introduced last chapter to Dent Car. So suppose now that Dent Car's long run total cost of repairing Y cars per week is 4y squared plus 144. If the price he receives for repairing a car is $24, then in the long run, how many cars will Dent Car fix to maximize profit? Well, if I know that the price that he receives is $24, I can set that price equal to marginal cost and see that that marginal cost is equal to $24 at 3 cars repaired. However, if he fixes 3 cars at a price of $24 each, that's not nearly enough revenue to cover his fixed costs. So as a result, Dent Car would have negative economic profit, right? So 3 times 24 is equal to $72 of revenue that he would generate. You see from his cost function that his fixed costs are $144. So he's not covering fixed costs. So in the long run, Dent Car is going to shut down, liquidate, and pursue an alternate career path. Okay, so and I've illustrated the red region as the magnitude of the losses that he would endure. Okay, and you can see on the math directly above me that his profit is formally negative $108. IRMA's production function. So IRMA sees X1 and X2 as perfect complements. The price of factor 1 is $5. The price of factor 2 is $8. Then what is her supply function? So we're given a production function. We need a supply function. This is actually an enormously important problem. So I'd ask you to pay close attention to this one in particular. So we're going to go from a production function to a supply function. So to do that, it's a multi-step process. The first thing we need to do is compute factor demands for factor 1 and factor 2. So if y is equal to the minima of x1 and 2x2, and then that the square root of that, the first step is just a matter of mathematical simplification. We can square both sides to get rid of the square root. So y squared is equal to the minima of x1 and 2x2, and I can rearrange this and I can see that to produce y units of output, IRMA needs y squared units of x1 and y squared over 2 units of x2. Because remember, for perfect complements, both of the things that are separated by commas must be the same. So they have to be equal to y squared. And that's where we got the factor demands. From the factor demands, we can come up with a cost function. So the total cost of producing output would be the quantity used of each factor times its factor price. And when we simplify all that out, IRMA's total cost function is 9y squared. Her marginal cost is the derivative of total cost with respect to output, which is going to be 18y. If we set 18y equal to price, what we know then is the output level is equal to P divided by 18, so that will be IRMA's supply function. And that will do it for Chapter 23.